Hello everyone, this is Vasant, a 9-pointer at IIT Bombay from the Department of Civil Engineering. In this video, we are going to discuss about bolts in shear and bearing stresses. So why this topic is important? Understanding bolts in shear is necessary for designing bolts and pins. See, we already know that to design a element, we need to know what is the maximum stress that element can be subjected to. So to understand that, we need to understand bolts in shear. Similarly, we need to understand bearing stresses to design the elements safely. So let us start. Bolts in single shear. Actually, these are in two types. One is bolts in single shear, another is bolts in double shear. First, let us deal with bolts in single shear. See, suppose if you take this example, these two plates are connected by the bolt, right? So you are applying force F in this direction and you are applying force F in this direction. Net force on the body is 0, right? Sigma Fx is 0. So it is in equilibrium. Let us assume that this bolt is made up of a cheese, okay? Assume this bolt is made up of cheese and you are applying force F in this direction for one plate and force F in downwards plate in this direction. So you are trying to pull like this, right? So if you observe, the cheese will break here, it will fail here, right? So this is failure plane for shear, okay? So we need to know what is the shear force in this cross section. So if you take body, whole bolt, so this is whole bolt. So on bolt, how is the direction of force? See, if you are applying force F in this direction, then if you consider these things, force F. So see, actually the bolt which you used here has some clearance diameter, okay? Means it is not wholly fixed. Means it is won't occupy complete area of this plate, okay? It won't occupy the complete area of this hole. There will be small clearance available. So when you are pulling plate like this, then which side of the circle will get occupied? This side of the circle will get occupied, right? This side will remain not occupied, right? So the actual occupancy will be something like this, okay, in this area. So there will be some clearance. So if we hole like this, then the bolt is occupied like this. The hole is occupied by the bolt, something like this, okay? This is occupied by the bolt. And this is clearance, okay? So when you apply like this, so the touch is here. So whatever reactive force developed, that will develop here, right? So here the force F will develop. So this plate will be in equilibrium. Similarly, a reactive force F will develop on this side. So this is the reason why we drawn this force F in this side, but we didn't draw this force in this side, okay? Means logically this is wrong, but it is right in some sense, but it is logically wrong because the bolt is in contact with the plate here. So the force, whatever reactive force developed, that should develop here, okay? Similarly, if we go to downwards plate, we are pushing the downward plates in this direction. So the clearance for downward plate, we take downwards plate. So we are applying force in this direction. So the clearance will be here. So this is clearance, okay? Understood? So the reactive force will develop here, F. So similarly, the reactive force on bolt will be like this, F dash, okay? That F dash and this F will be equal, right? So this is equals to F. Understood? Now take one half of the bolt, this half bolt, and draw the free body of this half bolt. to draw free body of this half bolt, then there will be force like this, and there will be shear force in this plane, that is in this direction P. So from equilibrium sigma Fx is equals to 0, we get F is equals to P. So what is shear stress? Shear stress tau will be is equals to P divided by A. So shear stress in the cross section of the bolt is given by P by A in case of single shear. This is case of single shear. Now let us go to bolts in double shear. So this is bolts in double shear case. If you consider this bolt, similarly now also assume this bolt is made up of cheese, and now you are trying to apply force in this plate. So when you are trying to apply force in this plate and this plate will resist. So they will create some reactive forces. So you are applying force in this plate. So if you draw the clearance diagram, means where the clearance will happen. So if you take this one, the clearance will be in this side, right? In A. Right? So this plate will resist in this direction, right? So the clearance will be for this plate, the clearance will be in this side. Here there will be clearance. Similarly for this plate also, the clearance will be, this is clearance. Right, so whatever reactive force developed here, that should be in this side. So whatever reactive force developed in this case, that should be in this side, right? So if we take this bolt, see what are the failure planes here. See, if you try to pull this one, then the failure might happen this and this, right? These are failure planes. You can think intuitively, the cheese will tend to fail in this section and in this section. Okay, so if we take free body diagram of this whole bolt, then there will be FC from this direction, because the clearance is in this direction. So the force, reactive force will develop in this direction, and here also the reactive force will develop in this direction, rightmost direction. So it should be here, right? So here it is F, and it is symmetric. So FC will be is equals to FD, and that will be is equals to, that is FC is equals to FD. So if we take this part, this K dash, L dash are failure planes. Okay, means where there is more chance of failure. So if you take this part, if you take this part of the bolt, free body diagram of this part, so that part of free body diagram will be like this. So similarly these are symmetric, so this P should be same. So again sigma Fx is equals to 0. So we will get F is equals to P plus P. So F is equals to 2P. So we get P is equals to F by 2. So in this case it is F by A, right? Sorry. So now in this case tau is equals to P by A, that will be is equals to F by 2A. So this is the case of double shear, holes in double shear case. Okay. So now let us go to bearing stress, which is also known as contact stress. Means when two types of material will get into contact, then there will exist a bearing stress. So if you see over here, this is the bolt, and this bolt and these plates are in contact. So here around these surroundings, there will be bearing stress. So what is the formula of bearing stress? If this is the place where there is contact, so we need to take the projection of that cross sectional area. If you take projection, that projection will be this, right? What is the area of that projection? Area of that projection is T into D. And what is the force acting on this? That is P, right? So the bearing stress sigma B will be is equals to P divided by that area, means P divided by P into D. Okay, this is the bearing stress, which is also known as contact stress. As this is perpendicular to the cross sectional area, so it is like sigma, right? Sigma is normal stress, which we already discussed. So this is about bearing stress or contact stress. One more thing is factor of safety. See, we know that we already discussed in basics of stress strain diagram that a material can sustain up to generally ultimate stress, right? उसके बाद अगर stress increase हो गया तो it will fail, right? If you remember the stress strain diagram for ductile materials, it will be something like this. So this will be sigma ultimate, right? So after this stress, if you increase more stress, then the material will fail. So you can design up to this stress, but actually you won't design up to this stress. You will design up to some allowable stress. So that allowable stress, this ultimate stress divided by allowable stress will give us factor of safety. Means actually it can sustain up to ultimate stress, but we design for less stress. Means we are more safer side, right? So how much safer side we are? To calculate that, we need to take ratio of ultimate stress to allowable stress. That will become factor of safety. But why we need to do this? Why we need to do this? Because see, factor of safety considerations, main thing which I can say is risk to life and property. See, if you are constructing a house, if it damages, how much loss you will have? There will be loss of human life also. So you will be careful, right? So you will design for less stress. So another type of considerations are types of failure, uncertainty of analysis, means whatever analysis we will do, that may go uncertain in case that is uncertain. So loadings, whatever loadings we predict, that may be uncertain. So uncertainty in material properties, maintenance requirements, importance of members to structures integrity, influence on machine function. So these all things are factor of safety consideration. Taking these into consideration, we design the structure to up to allowable stress. For allowable stress, that allowable stress generally will be less than ultimate stress. Okay. So with this, we end today's lecture. In next lecture, we are going to solve some problems on this topic. Until then, take care. Bye bye from ninepointer. Thank you.